गुड मॉर्निंग फ्रेंड्स। इन आवर लास्ट लेक्चर हमने अपने पिछले लेक्चर्स में रिफॉर्मर के बारे में और अमोनिया प्लांट और मेथनॉल प्लांट के बारे में ब्रीफ में डिस्कस किया था। द डिफरेंस इन अमोनिया प्लांट एंड मेथनॉल प्लांट is of CO2 section and distillation. Ammonia plant is having CO2 section and methanol plant is having distillation. In ammonia plant we need CO2 because it is the raw material for the urea carbamate which finally converts into urea. And in methanol plant we use CO and CO2 in combination with hydrogen in methanol converter to get the crude methanol in liquid form, and then this crude methanol means crude water, basically a methanol plus water. So we need to distill this to remove the water separately and methanol separately. So we need the distillation column. So two types of distillation column we have. First one is crude topping methanol column, and another is refined column. So in topping column basically the dissolved gases are removed, and in refined column at the top we are having the pure methanol product 99.995, and at the bottom we are getting the water. Intermediate around from the bottom around 10% of the tray location we take out the fuel oil. Basic purpose is to control the ethanol and other higher hydrocarbons which is not desired for the product methanol. So this fuel oil, actually whenever I will withdraw anything from the column or from any gas, when it is in the mixed form, we are losing the main reactant also. We cannot only extract the one gas from a mixture of gas. If I will take out, so in mole ratio this will come out. So we have to find economic method to utilize the value of the liquid or gas. So here fuel oil is having a value because it contains methanol, so that we are using in package boiler as a additional fuel. So there we are in one of our package boiler we are using natural gas, in another we are using natural gas plus fuel oil. Or if you have some other method to consume this fuel oil, then we can go for that. So as I told, the reformer is the main part of the ammonia plant as well as methanol plant. And in reformer key element is tube and burner, and normally this tube and burners ratio is 2.5 to 4. So tubes are arranged in rows and columns, and burners between the tubes, row of tubes we are staggering. So if suppose in one row tubes are around 50 or 60, then burner will be around 12 to 16. So that means कि one burner for a bunch of 4 tubes will provide the heat. So in reformer all burners for a particular it is same heat duty except the end burner, because if burners are in between then it will supply heat to both side of the tube, but end burners will supply it only to the one side of the tube. So that's why we are keeping the low heating value burners at the end, so that overheating or any uneven heating can be avoided. So other important part of the reformer is T and cone, and after T and cone the reform gas, hot reform gas at the temperature of 870 for the methanol plant and 770 for the reformer plant is going to transfer lines. So transfer lines, because temperature is high, so we are going with CS material, but to avoid the heating or the overheating of the material, it is refractory line, so that the skin temperature of the vessel is under control. And normally this transfer line we are making with thermosensitive paints. The purpose of thermosensitive paint is, if color is changing, then we will know that either refractory is having some issue or there is some crack or some passing. That's why temperature is going high. And if it is going white, that is the alarm condition, and there we are monitoring with the help of operation as well as CMI. And if it is going above certain limit, maybe temperature around 250, then we are providing steam hose to control the temperature, because if temperature will go high, then at a particular design temperature it will fail also. Failure means then the gas, reform gas, which is having LEL, because CO is there, CO2 is there, hydrogen is there, and so it will form a gas cloud. And if it is not controlled, then it may have result in valve formation. So that is a safety aspect. So that's why around the reformer we are providing hydrocarbon gas detectors, which measures LEL or CO. So accordingly, as per the design, this is provided on the FNG system. So if any leak or anything is there, we will immediately get noticed and the appropriate action will be taken. So for burner light up, there is a sequence is there. First step is purging. Purging means ki reformer burner box, it's a big volume, so we need to purge this volume by running the ID and FD. So during purging we are running the ID and FD at a high speed, so that the volume, normal operating volume in multiples is passes through. And then normally we are not going by the analysis, but we are going by the time. So we are going with a high flow of air passes through the complete reformer box for a fixed duration. So for first purging, normally it is around 20 minutes. Depending upon the reformer size and volume, ID and FD speeds are decided. So once purging is over, next step is proving. Proving means because furnace we are having natural gas, or it's a combined fuel, natural gas let down and topping, whatever the gases which are coming from the back end. So this gas which is going to the reformer, so when reformer is in stop condition and it is cold condition, so temperature will be around 25 to 50 degree. So at this temperature, if any gas will go inside the furnace, it will remain as a unburnt, because at 50 degree auto ignition will not take place. So once this gas will go there and it will be accumulated form, and when we are going to lit the burner, so during that time the possibility is that this gas, when it will get ignited, if it is in a small volume, then it will not a problem. But if a huge volume get exploited all of a sudden, it can be a reason for an explosion. So explosion is nothing else, a controlled combustion, you can say. It's a controlled combustion, but if it is uncontrolled, it will damage the furnace. And if the furnace will damage, then depending upon the volumes, in safety we are calculating the area up to which gas will have its impact. So for any vessels which contain hydrocarbon or any hazardous fluid, everything, as per the PSM, process safety management, we are calculating the effective zone or effective in the sense the impact on the human beings who are in the vicinity and the equipment. So it's all depend. It's all detail study, the amount of volume it is enclosed inside, then ignition sources, number of workers uh, exposed to that if it is there, whether in that area contractors are also employed, so number of manpower which are going or having in that area during that period. So depending upon the frequency of operation, people going to that area, casual people who are going for cleaning, for the instrument and electrical and mechanical maintenance, going for PM and other things, CMI for vibrations, and contractors if any scaffolding, anything. So depend upon the occupancy level. So all this risk assessment will be done, and accordingly guidelines were provided to be careful. Proving is done earlier manually, but nowadays it is a program is there. What we are doing, we are first take the burners in line, and then we are putting the nitrogen to make the header pressurize up to certain pressure, and then we isolate the nitrogen, and then we see whether nitrogen pressure is holding for some definite time. If it is holding, means the walls are holding, means individual burner walls which are linked to the furnace is closed. Actually during normal operation plant, when burners like 200 burners are there, they are all open NG walls, fuel to the furnace. So once plant is stripped, our operator has to go and isolate the each burner, manual isolation valve. If he forget to isolate any burner isolation valve, when we are going to lit the burner, then the NG will go to header, and if a particular header is lined up and NG wall is open, then this NG will go unburned because temperature is low, so it will not get auto ignited. It will go unburned and get accumulated inside the furnace. Although with new design we are having the combustible analyzer as well as oxygen analyzer, CO and NOx analyzer in the furnace, but this accumulation will be very fast, and if we are in the process of light up the burner, it can cause problem also. So normally for the safety point of view, we are putting the box under negative pressure, draft of -5 to -10. So in case when this combustion will go high, so ID will try to maintain this condition, but if the volume is high and it exceeds the ideal capacity, then the box pressure will go positive. Positive means the possibility of throwing these gases out of the furnace if any opening is there. In past peepholes from which we are seeing the furnace condition and taking the tube wall temperature measurement of the reformer were normally open, but nowadays it is covered and sealed with the glass. This glass can be open under safety precautions for replacement or as well as cleaning, because with time what is happening, refractory dust, everything get deposited on the things. For main burners, for reformer, normally we have experience of direct burners only, but for superheaters normally first we used to lit the pilot burner, which because of small size, so that in case burner took some time to lit up, unburned fuel quantity which is going to the reformer will not be very high. And then once pilot is lit, then we are going with the main burner. So normally the flow of the gas through pilot versus main is in the ratio of 1:10 to 1:15. So depending upon the furnace size and the proximity, we are deciding how many burners required to achieve the desired result. So normally for superheater furnace or some additional heating in convection zone like we are providing this burner. Even for the startup heater, before sending to ammonia converter or to methanol converter, but bottom fired burners are there. So in old plants it is all manual. Then in that case we have seen ki when operator is doing burner light up, sometimes pressure goes positive and it backfires also. I have observed in my experience ki mustache of backfire of the operator got lit up, and then he is having some heat impact on his face. One side of the mist was gone. So that is very old time when people were not fully aware, or sometimes we are in hurry. But nowadays fully automated systems are there, and still some places we are using the manual igniter, but slowly we are going for the automatic igniter. Then this all operator related risks are getting minimized. It's simple. The thing is that it is a balance between the skill operators costs versus the automation cost. So automation is good, but both way it's a win-win situation. So sometime to have a skilled operator, we can go by the manual operations also, because finally human mind replacement is not feasible, whether it's AI, latest technology, computer, or whatever. It is in any system, output will depend what I am feeding. So in AI also, if I will not feed the good, final outcome will be bad only. But it's an emerging technology. With time, we have to adopt these changes and we have to overcome the challenges. So as we are upgrading the technology and we are saying the pro and cons of that, so if you want to fit yourself, then certainly as we are upgrading the technology, we have to upgrade ourselves also with the skills, so that if our old skills are having no value in the market, our new skills make us survive. Darwin survival of fittest applicable is everywhere. So we have to keep updating ourselves with the latest technology, latest material, and whatever learnings are there in the plant or any failure. And always it is advisable to learn from other failure, because you cannot venture to do some mistakes and then you learn from that, because implications are very high, and its cost also involved. For one day, suppose if I am saying a 3000 methanol plant or ammonia plant around 1500 tons per day. So if 3000, if I am taking methanol plant, and roughly suppose if the cost is $400 per ton, so you can assume how much cost is incurred. So that's why operator skill, discipline, checklist, all is required to have reliable operation, safe operation, and on stream days. So on stream days is one of the indicator which tells about the organization growth, how organization is progressing. So one is this, as we are saying ki when we are coming to plant, first we see whether flare is lit or not. If flare is not lit, means plant is running. Although when plant is down, flare will not be there, but normally when I know ki plant is running, so when then in that context, when I am coming next morning to the plant, and if say see the plant flare size is less, then we are comfortable ki at least plant is running. Later we will see ki how efficient it is. So depending upon the flare length, one can see the condition of plant. If flare length is more, then we are going to check the PSV condition, whether any PSV is passing. In night, you can see the hydrogen passing also, if it is going to flare by the color. But hydrogen flame is not visible in daytime. So these are coming with the experience, knowledge sharing. So we are going to different plant also, as a cross functional team. We are sharing our learning. So in reformer, it's a big journey. Lot of failures we have seen. Tube failures earlier. We are when we are going through these studies. Sometimes we are laughing how people have done this big mistake. But human being and mistakes are the two coins of the. And once you will do some activity, certainly there will be some mistakes also. If you are not doing any activity, certainly there is no mistake. So you can do 100% perfect operation also, but as you know ki zero accident, zero mistakes is not there. So the only thing is that if any mistake is there, we need to capture it, we have to investigate it. Once investigation is done, it has to be formally documented, and then it's our role and our responsibility to communicate these learnings to the all staffs. And we can go for skill development with the help of simulator. Nowadays advanced technology, or we can have touch drill. Touch drill is that for various emergencies like cooling water failure, steam failure, anything. SPS or shift in charge, what he is asking the operator, if something happen, how he will act. So it's like a mock drill, but it's a physical. He will take, okay, he will tell, okay, this wall I will open. He is not going to do that in actual, but this the steps I will take. So actually the thing is that ki in any incident, either personal life or in plant, first 2 minutes are very critical. So if you are able to maintain your patience and response is good, you can handle emergency easily. So that is comes with the experience, knowledge, confidence, everything. So you see the reflex action when you are driving a car. If you are poor in reflex action, you cannot avoid accident. Similarly, for the plant, if you will not do action, then the things will go to alarm limit, and if it is further allowed, then it will go to the trip limit. Sometimes trips are there which take care if you fail, but in some cases it is expected the operator can manage it, so trips are not there. But although plants are there ki if it exceed the trip value, then it will go to design value. So for design consideration, already all pipes are designed, values are there, and above design value we are providing the PSV which take care of this excess pressure condition or temperature conditions. But even then, if this safety devices fails, the possibilities are there, so we can foresee the failure of the equipment. So in all together, it's a combined effort. One has to be very vigilant, has to go through the OEM manual, operating procedures, guidelines, and if we are following it properly, we can run with safe, optimized, and efficient plant. Thank you.